All right, welcome back to my second lesson of my LabVIEW introduction course. Today I'm going to be going over numeric and arithmetic operations. So we're just going to dive right in and we're going to start with operations we can do on the front panel. So looking at the front panel, if we right click on the front panel, it will pull up our controls palette, and we're going to look in the modern and then the numeric folder. Now in the numeric folder, we have all the controls and indicators that go with numeric values. So first thing we're going to look at is our controls. So I went and put together a couple of the different kind of controls that we can use to mess around with numeric values, and I put them in this little panel over here. So the first one is just our numeric control. This one you can type in a number that you want it to be, or you can use a little pointer here and change the number like that. What's happening here is this is basically once you have a number put in there, it's like a constant. That number will be used to input into any kind of equation or operation you're running through your block diagram. Same thing with these dials and sliders. They're just a different way of indicating a stationary number. So if you notice, when I spin the dial over here, the number that pops up on the screen in the little block is changing. That's because that's the value of the actual dial, what it will be outputting into the block diagram, that will be changing. And that's the same idea with the sliders over here, the horizontal and vertical ones. The thing is, sometimes you want to use sliders or dials because it cleans up your front panel and may be more concise for what you're using it for. So if you're using it as a speed control, yeah, maybe a dial will be a little bit better than just typing in a number. Also with that, with the dial and sliders, you notice they're only going from a range of 0 to 10. This can actually be very easily changed to be whatever range you would like it to be. What you have to do is right click on the dial, you're going to go into scale down here, scroll down, go into properties, and then in your properties, you'll see you have a scale tab, and you're going to change your scale range. So let's say I want it to be between 5 and 6. I can do that, hit OK, and now my dial has a range of 5 to 6, and you can actually see the decimal values on the ticks in the dial. So on the other half of that, we have indicators. Now this will be any output from our block diagram. So after you've run some numbers through an equation or any kind of operation and you want to show it back on the front panel what the result is, you're going to use an indicator. So an indicator, if I hit Control T, we can see our block diagram also. Our indicators can be hooked up directly to a control. So if I go from our numeric control to our numeric 2 indicator and I hit run, you'll see that the indicator will show what the value in that numeric is. And just like the numeric controls, the indicators have a couple different ways you can see them. So right now I'm looking at two numerics, and that'll make sense later, and I'm looking at a meter. Also, what you can do is when you add any kind of controller indicator, so let's say I also want to add a gauge indicator, you'll see once it's added to the front panel, it'll automatically add a block to the block diagram to be used. So now any one of these controls can be connected to any one of these indicators. So as I was saying before, that's why we're going to look at the numeric indicator, because we're going to put a slide control on it. So now if I run this, again, it's hooked up to slide. You'll see that the slide value is set to 5, and now this numeric indicator over here is also set to 5. And that's the same for all these dials connected to the meter and the gauge. So the next thing I want to cover now is what can we do in the block diagram? What kind of operations can we do in the block diagram? So what I'm going to do is I'm going to go over here, I'm going to create a new control, and I'm going to create a new numeric indicator to show the output value. So LabVIEW is interesting because it allows you to do work on functions like other programming languages, but it's actually a lot simpler because it comes in a block building format. So what we're going to do to get those blocks in the block diagram is we're going to right click on the block diagram, we're going to go into our functions palette, and now we're going to go and look at our numeric to bring up any kind of numeric operator. The first thing we want to do is just a pretty easy task. We're going to add two numbers together. So we're going to pull the little add block down, and you'll notice if you hover over this, it has two orange points on the end of it and one orange point at the opposite end. These two orange points, if you hover over them, are an X and a Y, and then you'll see the output is X plus Y. So that means you can input two values into this block and it'll output the added value from them. So we're going to add another control over here so that we have a second input, and we're going to plug that into here. So what we're going to do, we're going to drag a wire out of that output from the control, drag a wire from that output, and then we're going to take and drag a wire from the output of the addition block and pull it to a control. So now what the idea here is I can take, and I have two numeric values, so let's say we have 2 and 3, and what that block is going to do is add them together and display the added value in this indicator over here. So if I hit run, 2 plus 3 is 5, so the block is working just fine. And now this works with any other block in your numeric. So let's say I have a subtract, let's say I have a multiply. Oh, didn't want to connect those, we're going to delete that. And let's say I have a divide. So now if I go and hover over these, I can see we have an X input, a Y input, and it'll be X minus Y. X input, Y input, X multiplied by Y, and an X input and a Y input, and you'll see that it's X divided by Y. So it's a very powerful tool, and you can add those up. So now let's say I want to do multiple steps, and I'm going to have constants in there also. So instead, if you have a constant value that you want to plug in and you don't want to make another control just so you don't clutter up your front panel with constants, you can also make constant values. So we're going to delete these wires. And let's say I want to add those two numbers, but I also want to multiply it after by 2. So what we're going to do is we're going to go into our numeric functions again. We're going to go down to DBL, Numeric Constant. We're going to pull that up to here. And now I have a constant value that I can change. So this will constantly output whatever value I want it to be. And we want it to output 2. And now we said we wanted to take those added numbers and multiply them by 2. And then that'll be our output. So we're going to take our 2, put it into one of the inputs. Now we're going to take the output of the X plus Y, put it into our multiplication block, and then reconnect these up to the front of this. So now, basically what this is showing is we're going to have X plus Y, and we're going to put those in parentheses because now we have X plus Y, and then we're going to multiply that all by 2. So that's what this is showing. X plus Y multiplied by 2 will give us our output. So if I run this again, you'll see we have 10, which makes sense because 2 plus 3 times 2 will equal 10. And this also goes into showing that data flow operation of LabVIEW, because we can see that if we start over here, all you have to do is follow the lines and the data will flow through the course of the lines. So that means no matter how long this program is, it'll go step by step down each line till it gets to the output. So some other operations in the numeric I'd like to look at are our quotient and remainder. This is an interesting tool because you have two inputs, and 2 outputs. So what's going to happen is when you input 2 values into that, so let's say I wanted to do this value, x divided by y, what's going to happen is you can just do a normal division and get a quotient out of there, so like that, or you can also have a remainder from there. So the remainder is, let's say I do 5, which one's x and which one's y? So let's say I do 5 divided by 2, and I want to see what the output remainder of 5 divided by 2 is. So I'm going to hook that up to the R output terminal, because that's our remainder. Where's our numeric? That just appeared is at. I'm going to pull that down. So if we do 5 divided by 2, we're going to see we have a remainder of 1, because at most 2 can go into 5 twice, and then that's going to equal 4. 5 minus 4 leaves you with a remainder of 1. That's a powerful tool if you're trying to find whether or not a number is odd or even. Next one we're going to look at is round to the nearest value. So this will take a value. So let's say we input a DBL. We're going to put in a DBL constant. That brings up another good point. DBL, there's 2 different kinds. You have a numeric constant and a DBL numeric constant. A numeric constant, the blue ones, that's just going to be regular numbers, so 0, 1, no decimal points. DBL allows you to use decimal points. So I prefer using DBL most of the time, but it's kind of up to you whether or not you need decimal points in what you're doing. And if you do, the program will automatically update your value to a DBL, so you'll be all right in that case. So what's going to happen is I want, let's say, 0.55, and we have our round to the nearest value. And we're going to just take another indicator. Ooh, that one's way up there now. We're going to take another indicator, and we're going to hook that up to there. So when I run this, you'll see it automatically rounds it to 1 because it'll round it to the nearest whole number. Some other things we can use, a compound arithmetic. What this does is it will take as many inputs as you can feed into it, and it will add them all together. And if you right-click on it, you can change the mode, and you'll see from changing the mode, you can have it multiply all the numbers you want. You can have it and or XOR also for the numbers you would like to use. Most of these values in here, there's a lot of documentation just in the program for how to use. I'm just going over some of the major ones that are used quite often. Another one you'll see is your random number generator. What this is going to do is it will, when run, it will generate a random number. Gotta copy this. It'll generate a random number between 0 and 1. So if I hook this random number up to there, and we have floating parts, delete that, and I run it, you'll see that every time I run it, it'll give me a different random decimal number between 0 and 1. And that can be used for random number generators, so on and so forth, and if you need to randomize your program. So before I have you do a little homework assignment, the last thing I'm going to look at are some of the extra folders in here. In the conversion folder, there are little tabs that allows you to change what type of value you're looking at. So if you have a double precision floating point, you can change it to a DBL, SGL, a fixed point, unsigned quad integer. There's tons of things in there you can change it to. The other one is if you're running in zeros and ones, you can change it to a Boolean, so a true-false statement, or you can change it to array. There's a whole lot of conversions that can be done for your numerics. Also, another one is your mathematical constants. So if you don't want to type out the value of pi, 2 pi, pi divided by 2, your Euler's value, your log 10s, things like that, they have a library of constants that already come pre-programmed in that you can use and just draw from there. So that kind of covers the basic of numeric values. What I'm going to have you do now is on another tab, if I pull that up, I have basically a problem for you guys to try to figure out. I'm going to give you time to pause the course, and then you can figure it out, and then I'll go over how to do it after you've worked through it and stuff like that. So what we have here is the problem is you want to find the total balance using the parameters given. And so this is a basic equation to find how compounding interest affects the balance in like a bank account. So the equation you'll be using is B equals principal times 1 plus your interest to the power of n being the number of years it's been sitting there. So what we have is our principal is going to be equal to 10,000, so that's our initial value in the bank. We have an interest of 3%, so 0.00 or 0.03, and we have 10 years that we'll let it sit there. And now I'm going to let you pause the video because in the block diagram, I would like you to recreate this function and have it run in the balance. So pause now, and pause the video now, and once you unpause the video, I will be going over how to do those calculations. All right, welcome back. So what we're going to be doing now is we're going to do those calculations ourselves. So we want to break apart this program. Since this is data flow, we want this to flow properly. So what we have is we need to do, since these are in parentheses, our 1 plus I is what's going to come first. So what we're going to do is we're going to go into our numeric. We want to pull an add out. We're going to hook that up to our interest. And then on our Y input, I'm going to right click. I'm going to hit create and I'm going to click constant. Now what this does is it skips the step of having to go into that numeric folder and you can just draw a constant right away. So what we have now is we have our 1 plus I. After that, if we look at the equation, we can see we have I being put to the power of n. So that means now we need our interest and our number of years. So if we go into our numeric, we can see, we're going to need to go into our mathematics actually. We're going to go into our elementary, we're going to go into exponential, and we're going to do a power of x. So this is one we haven't looked at because this is going to be in our mathematics. So what we have here is we have an x value and a y value, and on the output, it'll do x to the power of y. So if you notice, we need 1 plus I to the power of n. So we have the output here will be going into our x, and we need it to go to the power of y, so we're going to have it be n to our y value. And now the output here is going to be equivalent to 1 plus I in parentheses to the power of n, our number of years. And now all we have left is we want to multiply this by our principal. So we're going to do, where is our numeric? We're going to do numeric multiply, and we're going to do principal times the output here. And now that output is going to be equivalent to, we're going to copy this. Principal times that. And if you notice, that is the same output we would have liked from there. So the multiplied value will go into our balance. And now we should have a working program. If you're wondering what these little tabs are down here before I run this, these are comments. These actually don't affect the program. I'm just documenting what I'm doing. So those have no effect to the program. It just documents what I'm doing. So now if I run this, you'll see my final value after 10 years will be $13,439.2, we'll say, dollars. And now how this is working, if we go into our highlight execution, we'll be able to see it work in real time. So what happens is we go there, we get the exponential, it happened kind of fast. We get our exponential, and then from our exponential, we multiply it by our principal, and we have an end balance. If you don't like how all of this looks, this little button up here in the corner, clean up wiring diagram, you press that and automatically shrinks everything down into a more viewable version. So that's the end of lesson 2. I hope you enjoyed this video. If you did, please like and subscribe because there will be more coming along the way. If you do not have LabVIEW to work these problems with, you can also write them down on sheets of paper. Because you can just draw out the little diagrams as you go. And you can also test these by just running it through a calculator to see if it works. I hope you found this enjoyable, and I'll see you in the next video. Thank you.